Hey everyone, my name is Luke and welcome to my channel. Throughout the course of this video I'm going to take you along as I go through the process of building the second pier for my observatory. The one that the EQ8 is actually going to sit on right here. As I go through this process of actually building this pier from start to finish, I'm going to show you the materials I've used, the techniques, and basically try and explain why I've gone about things the way that I have. It's not really a standard approach to building a pier, but I have already took the chance to build one other, as you can probably see just over there. Chloe's pier is already built and in place, and it's been tested, and I'm extremely happy with the design. And I think that anybody who builds this kind of thing would be too. So before I go through the process of actually building this EQ8 sort of base pillar like I've built for this this one over here, I thought I'd talk to you about the process and the materials that I've used right now on this completed pier while it's in front of you. So bear in mind there's probably going to be a little bit of shoddy camera work here as I've got the camera in one hand and I'm just going to be trying to point things out to you with the other, but all the same, this is what happened. So basically this is the second time of building this pier. I made it first using standard construction techniques and just mortared everything together as you would for like a brick wall. Now, it felt okay, it felt pretty solid, but I thought before I actually put anything onto this and start mounting weight and valuable equipment and such, I wanted to give it a little bit of a test. I thought that were a reasonable thing to do. So basically, for want of a better explanation, I just grabbed hold of this top block and gave it some twisting force and lifting force, and I wanted to see if I could wrestle it free, basically because I thought if I can't do it, then there's no way that the weight and like forces that this telescope is going to exert on it is going to cause any sort of issue. But the problem was I could. I actually broke the bond between the mortar and the blocks, and that was enough to make me kind of think there's no way I can go ahead with this. So anybody who's kind of a bricklayer or anything like that, I assume you'll already be laughing at me at this point, but for anybody who doesn't know, I mean, mortar's great at compressive strengths, but it's really quite weak when it's put underneath a tensile load, such as maybe you mounted the counterweights on your mount but I haven't got the telescope on yet. There is the chance you could crack this top block off, and I didn't want to entertain that idea at all. So I went through the lengthy process of deconstructing the rest of the pier once I decided mortar was not going to be the option that I could go with. Cleaned up all the blocks, cracked the mortar off using hammers and chisels, and then wire brushes to clean everything back up. Anyway, got them clean. Long story short, I decided I could not possibly go down that path, so that's when I settled on this instead. Now, this is a high strength polymer adhesive. There are loads of different types of this stuff available. Gorilla Glue, Evo Stick like this. But this is a proper solvented adhesive. It's not a water-based thing or anything like that. And I bought this because it was basically the top end adhesive in the store that I went. I asked people in there, the kind of store workers, what would be their recommendations for bonding concrete blocks together, which is what these are, the concrete foundation blocks for building homes on. And they recommended this because it sticks to wet surfaces. It basically states itself, it'll bond wood, MDF, plaster, brick, tile, ceramics, plastics, PVC, concrete, you name it, it will stick it, and I believe it because it's awfully sticky stuff. It seems like it would just about bond anything, but also the bond strength was incredible. I guess it's under perfect situations, but what they state, Evo Stick themselves with this polymer adhesive here, is that a 4-inch patch that is 100 mils by 100 mils is able to provide a 350 kilogram bond, which is that's going nowhere basically. So when you scale that kind of bonding strength up to something that's the size of these concrete foundation blocks, which is 12 inch by 11 inch or 300 mil by 275 mil, that's going to be a bond that's way stronger than the actual blocks themselves, I would imagine. So that's the route that I went. I decided I was going to try once more and use this adhesive, and I'm really seriously glad that I did break it that first time, because this is just by far and away a much better way to do this job for me. So as you can see, the whole thing is actually mounted on an old style damn near 3-inch thick flagstone. These things are heavy. They're not like the kind of thin ones that you can buy these days. These are the old ones, but no doubt you can buy things like this anyway. But basically underneath this I put an absolute bunch of this stuff and then really twisted the block around to sandwich itself down so it could bed itself into that adhesive and get a great bond and a large contact patch. That basically effectively tied together this set of 4 flags, which is just touching. I kind of measured from the walls and stuff like that and determined that that was the point that I wanted to fit this pier in. So once I'd got that down, you can actually start work on the rest of the blocks straight away. So I just cleaned things up, as you can imagine. Made sure it was free of dust and anything else that might compromise the bond, anything loose. I actually went through the process of, once I'd kind of cleaned them, I hoovered the blocks as well. I've already done that with these ones, so these are dust free. But yeah, then I went through using tubes of this, effectively putting down a perimeter layer, some layers in between, and then plonking each block on top of the last and really kind of twisting them in so that the adhesive would get a good squish, if you like, and I'd almost be left with no gap whatsoever. As you can see, it's practically a concrete to concrete interface with just a very thin sandwich layer of this stuff, and that seems perfect to me because it's effectively bonded them together with the integrity of one block, or so it feels like to me. I did do the same test with this, gave it a good wrestle around, and there was absolutely just no way. I think you'd have to kind of hit it with a car to get this thing to come loose now, or destroy the blocks completely somehow with sledgehammers and a lot of sweat. But yeah, that is basically the process that I'm going to go for actually building this part of the pier. So it's going to be effectively a flagstone to tie together the base, to give it a larger footprint, to make sure that no wobble can occur. I'm really pulling on this thing now, and there's nothing kind of going on. And then build up concrete foundation blocks, as I've mentioned. That's what these are. They're 12-inch by 10-inch by, I believe, 6-ish inch, 5.5 inch or something like that, 140mm anyway. And that's what I'm going to be using for this construction. They are rated for things building on them. So I thought, why couldn't they put up with the weight of, maybe at most 50, 60, 70 kilograms of telescope equipment. If you can build a house on them, I'm sure it can support that little bit of a load. But yeah, that's what I went with, and that's what I'm going to go through right now. But the next part of the construction after that is going to involve steel plates and kind of off-the-shelf hardware, which made sense to me to use because it's really easily repeatable for people. I actually didn't even buy a Pier adapter plate. As you can probably see, if I just zoom in a little bit here, I just took the legs off my EQ6 tripod, I've stowed them away down there, and used the adapter plate that's already built in effectively to that tripod. That works fantastic. It's just an M12 rod that I cut short that goes up into the threads on the bottom of that thing, and I've tied it up with a nut and washer. And once you crank down on that thing, it's going absolutely nowhere, I promise you. There's no way I could get this thing loose even if I wanted to. As for the plates themselves, I went for 10mm thick steel plate because it's like tank armor. It's just so strong when used on a scale like this that it's the perfect thing. Basically, there's no way, again, that this could be a weak point in the build. M12 coach bolts I used on this. There's probably got to be better alternatives, but this was what was available at my local hardware store for a reasonable price. You could also buy threaded rod and cut it down, I guess, but this turned out pretty neat all the same. And for this, I've used just kind of stacked nylock nuts on the bottom with a washer through the plate, with a washer, with a normal no, I think that actually is a nylock. Just correct myself. And on the way up, as you can see, I've just done the same thing again and again. Then you can bolt each plate to the next, and then you've got a self-leveling mechanism. So you can kind of, let's say, that this corner of the pier wants to come up. I hope you're able to follow along with my waffling here, but let's say if this corner of the plate needs to come up for leveling, you could just back off this top nut, tighten up the bottom one, and you'd push the pier plate kind of up. And I did level it up that way, and it's worked absolutely perfectly. So that's what I went with. And as for a final point as well, how to connect the steel plates to the concrete blocks, well, they've developed a really smart screw for that. It's actually a concrete anchor screw. These are 150mm length, so they're actually longer than the blocks are, but because I've got a standoff, which I needed to kind of put these plates in here. Excuse my shoddy paint job. I used a small stack of washers to transfer all the clamping effort through from these bolts down into the block, which I kind of drilled out with just a masonry bit all the way down into like the next block beneath. So it goes deep, but these clamp down extremely hard. They are purpose built for clamping tall concrete blocks effectively, and they do the job perfectly. They're not cheap, but as you can imagine, why scrimp on the part that actually really matters? This is what's holding everything kind of to the pier. So I realise I've gone on extremely at length now, and probably most of you are asleep. So I'm going to go ahead now, start clearing away my telescope and the mount and all this, and basically sweep the floor and get it ready for a time lapse, as I'm going to make this next pier right now. Alright guys, so the first job is actually done. I've got the mount and everything else out of the way inside of there. I'm just taking a time lapse actually as this goes on, but I thought I'd just kind of point out to you exactly what it is I'm doing right now. So I've just dry fitted this flag onto the floor. I've measured it across multiple spots, so from here to kind of the foundation, from here to the foundation and out, if that makes sense. So now I know it's centralized inside the building, and to make it so that it's easy to put back down once the adhesive has gone down, I also put down just a line of masking tape there, so I know when the edge of this block is lined up with that, it's perfectly central inside the building. I'm going to do the same in just a moment for kind of getting it exactly how far away from this dividing wall that I want it, and the distance to the next pier. But basically that is largely done. I just need to do a little bit more measuring, but I want to kind of point out to you the method by which I went about that. So that's ready to go. The other piece of tape just down here is actually kind of pointing perfectly east-west. So if I just did this with my finger, if you like, that makes a cross, this would be the north-south line. So basically I need to make sure that these blocks, I did the exact same thing with this other pier. So you can see the base block is lined up with the rest of the flagstones in the building, but the kind of secondary blocks that the pier and its plate is going to stand on, they're aligned north-south. So I just thought I'd point that out to you and get on with the rest of the build now. Alright then, so you can probably see the foundation block, the flagstone itself, is now in place, all measured, squared up. I actually dropped that down into place twice. So I dropped it once I'd put down a good layer of the polymer adhesive, pried it back up, just lifted it back up. Not that easy actually, even by that point. But anyway, yeah, pried it back up, looked for any points where the adhesive had kind of been pushed, maybe super thin or maybe hadn't contacted at all. Just topped it up wherever it needed it, dropped it back down again, gave it a good twist to kind of settle it right down into place, and then, honestly, as daft as it sounds, I just jumped all over it to kind of really bed it in against that base stone. After finishing that, basically, I popped the first stone in place, took my time to measure this and get it all central and squared up with the kind of east-west, north-south lines. So I'm satisfied that that's good and central inside this block now. I used just measurements, of course, from each of the points of the block in and out. So this happens to be 29 centimeters from each edge. And basically it's good to go. That was the hardest kind of part, just making sure that one's measured. The rest of it is just going to be a case of adhesive on top, squiddle it around, put the next block on. Really fast. Just thought I'd show you this little technique that I'm using here to make sure it's kind of spread out thin. So I just put down the layer. I'm now leaning on the block and giving it a good twist to hopefully spread everything out. It's getting quite difficult to twist at this point. Spread everything out and make sure it's got the largest contact patch possible, so the maximum amount of bonding strength from that adhesive. Alright guys, so as you can probably see now, I've just got finished building the actual main body of the pier itself. So I finished the time lapse, spent just a couple of minutes while I could still work with this stuff, kind of squaring the edges up and such, if that makes sense. So making sure these follow as nice as they possibly can, with these being just like a foundation block. They're not quite maybe as neat as, say, an engineering brick or something like that, but they're more than adequate for this purpose. And because I'm already working from a level base, I didn't actually have to worry too much about getting these blocks down level, as I'm using such a thin smear of adhesive. It's not like kind of putting these down on mortar where they could tilt quite a lot. Instead, I'm just relying on the dimensions of the blocks, keeping things just about level. Doesn't matter anyway, because as I talked about earlier, any final leveling can always be done just by adjusting this top plate and the bolts that kind of hold it captive. So all that's left to do now is give this some serious time to dry. Now apparently you've got like 10 minutes to actually really work with it, 40 minutes where it's just about movable. In 24 hours it'll reach, I do believe it's said about 90% of its bond strength, and then over the course of a full month it will fully cure to 100% of its bonding capabilities. But anyway, tomorrow, basically roughly 24 hours from now, I will hopefully be drilling into this and attaching the top plates for my pier. The steel is here. Again, I ordered 10mm thick steel plates. I think I ordered 300 by 200mm blocks, so they're going to be way strong enough for this application. Even for the mighty EQ8, it won't have a chance of rocking those whatsoever. Well, here we are. It's the next day now. We're probably about a good 15 or 16 hours on from when I put the last block onto this pier. As you can probably see, it's setting up real nice, and it will continue to just kind of harden as it goes off fully over the course of the next maybe month or so. But it's more than usable by this point, I would say. So I want to get on and get this thing completed. So as you can see, I've just got dry fit onto the top of this, just totally loose at the minute. One of the 300 by 300 by 10mm thick metal plates. I've got this on here basically because I'm just looking at roughly how it's going to fit. It fits perfectly back to front. It overhangs ever so slightly on the sides because these blocks are 300 by 275. That's expected. But the next thing I really need to do now is get this marked up. This bottom plate is going to be the simple one because, as you can see, effectively, if I just take you over to the EQ6 one I made here, it's just going to be some corner holes matched up with the top plate and 4 spaced out bolts, holes in the bottom for the concrete anchor bolts to go through. The top plate, which I'm going to do afterwards, of course, is going to contain some of the same holes. So these edge ones for my kind of separating bolts, for want of a better explanation. But then I'm also going to need a perfectly centralized bolt for the M12 main rod that's going to go into the bottom of the EQ8 to kind of clamp that down. I'm also going to need a hole drilling for the azimuth pin, which I'm going to take from the top of this, if you can just see over here, on the EQ8's actual tri-pier. So as I said, an M12 central, I think this may be M8 or maybe M10, the azimuth adjustment pin, and then there's going to be 2 M8 kind of holes that I need to drill and tap effectively in that top plate, but I need to get those perfectly apart. But luckily online, someone, I've just done a little bit of googling around, if I just spin the camera around here, someone over on Stargazer's Lounge very kindly provided this schematic, so it gives me the absolute distances center to center for all of these measurements. It's been really nicely put out. Also, the rest of my gear arrived, so excuse the shoddy camera work, sorry if I'm making you all dizzy. But here's the rest of the stuff. So I couldn't get any more of the long concrete screw bolts, so I'm going to use these old ones that I've got laying around, 90mm long. There'll still be a good 60-70mm, I think, going into the concrete in 4, maybe 5 places depending on how many I drill in. That's still loads and loads. They really do get a good grip into those blocks. Here are the coach bolts. As you can see, the exact same as I used on the EQ6 plate adapter, just M12. A brand new drill bit to make drilling all these holes through that 10mm thick steel go just that little bit smoother. I've also got the drill press out of the workshop, and I've put it outside ready to use. A pack of M12 nuts and a big pack of M12 heavy duty washers, so they're quite thick, as I am going to use some of those for kind of standoffs from the concrete block to the bottom plate, to give me a little bit of room to get these in. Anyway, the next thing I need to do, as I mentioned, is get these plates marked up, so I'm going to get on with that job right now. I thought a quick section talking about how I'm actually going about marking this plate might be useful to some people, so I'll just quickly tell you the tools that I'm going to be using for this. So I've actually got like a metalworking scribe right here. As you can see, it's just a very sharp, very hard metal point on each end of this, and I'm also going to be using simply a woodworking speed square, as it's just really good for all this. So let's say, for instance, I'm going to mark one of the edges. So in each corner of this plate, I'm going to have one of those M12 coach bolts coming up through. This is in both plates, so I'll need to do all these marks again. So they need to be repeatable, so that when I put a bolt through, it doesn't kind of get caught on the sides and is hammering through, filing the holes wider, or any messing around like that. I'd rather get it right the first time. So that's why I'm going to spend some time with my marking. But anyway, let's say, for instance, I want it to be 1 inch in from each edge, like perfectly in the corner here. You really wouldn't want to guess this. So instead I'm going to use this square. As you can see, it's got a flat edge down one side, which means that when you put it up alongside something like this, which is a known geometrically perfect shape, it's been cut out by a water jet, I think. It's been done by a computer, not by a person, so it's guaranteed basically to be just about perfect. I know that if I drew a straight line down here, it's going to be perfectly square. Now, if you'll notice on the speed square itself, it's got gradations, so you've got a 0, 1, 2, 3, 4. These are all in inches, of course. I want an inch by an inch out, so I'm going to push this up to the side, make a small mark here at 1 inch, just by scratching the metal with the edge of this. So now I've got that, whoops, nearly through this, I've got that little mark in there. I can basically turn this around, match this up perfectly to it, again we know it's square, and elongate that mark ever so slightly like this. So now I've got a good clear mark 1 inch in from this edge. Now I need to do basically the same sort of thing but going across. So I'm going to leave it down on this edge, coming in from the 1 inch mark once again. Alright, I've got a little mark to go with there. I'm now going to put it across this side, come up to the mark that I just made, clamp it down with my fingers, and make sure I've got a good mark. Now, if I just try and zoom this in just a little bit and get you pointed to where I've just been working, just on this corner. You may see that I've got a small, hard to see mark right there. Now, if ever you've drilled metal like this before, you'll probably know that without kind of a punch mark, your drill bit's going to want to kind of skate away. So you'll take all this time marking, but if you don't make a punch, it was probably for nothing. So to that end, I've got a little metal punch here, which I'm going to put right in the intersection of that cross. Give it a good tap, and now we've got an actual proper indent that I can put the tip of the drill bit into. I'm going to put this through first with a pilot hole, a small sharp drill bit, and then I'm going to go through again and chase that hole with the 12mm drill bit, rather than trying to go through and remove all the material just in one. But basically, I hope that's been helpful. That's how I go about marking this thing. So I'm going to get on with this now. It's probably going to be a little bit of a time-consuming task, but well worth taking the extra time to get this right the first time. I don't want to be doing this twice. As you can see, I got done with all the marking tasks on both plates. They're just the other one's waiting over there by the little drill press. Basically, I've done every single pilot hole by this point, so I punched them, pilot holed them. This is the top plate, so this has got one in each corner, as you can see. A central hole which I've had to drill with just a hand drill like this, because the standoff on the drill press doesn't go far enough to reach the middle of this. This is 150 millimeters from the edge, and I think that'll do 120, so it was a little bit short. But anyway, I've got that hole, that one's finished. Now I need these two side holes. So here's one and here's another. From reading the specs online, it looks like these are M8 threaded, so they should be. So I'm going to need to tap these out. But first, after this pilot hole is now finished like this, I need to use one of the bolts. I've got my little tap and die kit here. These are the bolts in question that kind of clamp the EQ8 to the plate, if you like, and because I know what these are M8. You could use your thread pitch measurer just down there, and I have just give it a quick double tap, a double check, sorry. But M8 by 1.25 millimeter thread pitch. It needs a 6.8 mil pilot hole. So basically, I'll take the, I assume this one. That's a 6, I think. So it was the next one up. I don't know if the camera's focusing. That's a 6.8. I'll take this, run through those two holes, that one there and that one there. I'll then put, this is the M8, this tap into this cutting lever, and basically with a little bit of WD-40 or oil or whatever, I'll gently work this through, going back and forth and cut myself a set of threads. Again, I'm really sorry about the shoddy camera work on this. I'm just trying to catch things as I go. There is one final thing you can do just to double check if ever you're making cuts like this. You can kind of just push the tap and the intended screw together, and if the threads mesh like they do perfectly on this, you know you're going to be using the right size tap, so you've got no real worries. So I'm going to go ahead and get those two cut right now. I won't tap them just yet, as I've got a lot more holes to be drilled once I get this 12mm bit into this drill press. So I've got the work here just sat on top of the drill presses, kind of really undersized table, and I'm just about to make this second hole for the M8 tap to run into. So I'm just lining it up first by eye, and with most of the weight of the plate supported on my hand, I'm now going to start the drill. Make sure you've got your glasses on at this point, and just gently let it touch up to the work, so that when the bit starts to skate, it'll do any final alignment for you just with the pressure of the bit. So now I'll steadily push through, and this should be finished in just a moment. It's literally going to be a case of rinsing and repeating that over and over again now for a good while. I've just gone through now, drilling every single hole for both plates. This one that you're looking at right now is the top plate, so it'll actually be in that kind of orientation, with the azimuth adjustment pin for the EQ8 facing south. The two clamp down bolts, east and west respectively. The central bolt is there for clamping the whole thing down, and these are the side bolts, which are going to be my level adjustment. If I just kind of pinch this plate a second and jump back up here, here's the bottom plate. So this one again is going to have the edge adjustment bolts for leveling and keeping the two plates just a little bit apart. And here is where the concrete bolts are going to go straight down into these blocks. I'm going to kind of drill the holes for those right now once I've lined it up and got it kind of to the point where I'm happy with it. I've already got a masonry bit put into this thing, and that's literally the next thing to do. So once I've got this plate bolted down, I'm going to sandwich a little pack of washers in between each one to give it a small standoff. It's not perfect, But this is all just DIY stuff, and it will work. It has worked on the other one at least. Once that's down, I'll then attach the second plate, the kind of top plate, to this, and I'll do any tapping jobs. So I need to do some M12 threads to be tapped. That's for the azimuth adjustment pin, and M8 threads for those kind of clamp down side bolts for the EQ8 itself. So I'm going to get on with that right now. I've got the both kind of plates now roughly just in place. Nothing's tightened up just yet, but it's certainly tight enough that I can now start to tap out those holes that I drilled. So as we know, I needed an M8 thread for these two, which would go on the east and the west hand side, and I chose to create my own azimuth pin. I'm just going to use a small piece of M12 threaded rod. So in there I put a appropriately sized pilot hole for the M12 by 1.25 tap. So I'm going to run all of these taps in, get these holes nice and threaded and ready, and then it's literally just a case of tightening everything down, making sure it's all level, and cutting a couple of pieces of threaded rod. One for the central bar, which I'm going to tighten down into the bottom of the EQ8, and just one to act as an azimuth pin, and then we're pretty much good to go, and this will be a completed pier, aside from taking it apart someday to just repaint it. Alright, so everything is just about in place and ready for the mount. As you can see, I've got the piece of M12 threaded rod just tied on with a nut on the underside into this threaded hole. That's going to act as my azimuth adjustment pin. The central bolt hole is already in place with some nuts on the bottom, so I can tighten that into the EQ8. But as you can see, currently we're nowhere near level on this thing. So, of course, I need to get this tightened down hard first, and well, at least up against these stops, and then it's going to be a case of lifting and dropping each side until we reach level. So as you can see, it's a lot closer if you can see that bubble just there, but it still looks like this side needs to come up just a little. We'll do that just to give you an idea of what it is that I'm doing exactly, so you can see the bubble just moving ever so slightly there. And once more, and I think we're about level in that plane. Of course, I'll double check this if this needs adjustment. As it happens, it's perfectly level. Back and forward, it was just that left and right. So now I'm going to kind of take my time, tie everything down. These locking nuts on top. Make sure everything's still level once everything's tight. And then it is time to actually put the mount on. Oops, some step ladders in the way. Alright. Well, it's finally in place. I just needed to make some small adjustments to the azimuth pin. Nothing too drastic. I just kind of undid its locking bolt and pushed it further up into the mechanism so that the side bolts could engage. But everything is in, and hopefully you can see it's rock solid. It really is impressively strong with this sort of construction. So it's all in place. Basically all that's left to do is get the scope on it, the counterweights on, and roll this roof back, because as luck would have it, I've got a clear night tonight. So I think I'm going to enjoy just a little bit of a session, have some fun, get this thing polar aligned as accurate as I possibly can. Well, I think that's about everything for this video. Hopefully anybody interested in making one of these piers on their own would be able to follow along with this in some capacity and come out with basically the same result. I would do it again, honestly. If I was making another pier, if I had an even bigger observatory and could install a third pier, I'd just make another one of these. It's cost effective, it's time effective, and there's really no wasted materials. it's all positives. It's come together extremely strong, and I'm very pleased. But anyway, I realise I've gone on and on and on at length during this video, sometimes rambled, but hopefully it was watchable. So I think I'll cut it short before I go on another tangent. So as always, guys, thank you very much indeed for watching. I really do appreciate every single one of you, as I always say, and I think that's just about everything for today. So until next time, take care of yourselves and clear skies.